Hello, my name is Persad. I am the co-founder and CTO of ASTREAS. ASTREAS is a startup that is focusing on space nutrition and countermeasures and developing food systems for human spaceflight in long-duration space missions. So one of the questions that we've been pondering at ASTREAS is how should a futuristic space station look like in terms of food handling and food preparation and food production? And we're narrowing our scope. And in the context of the Cultured Meat Symposium, one of the questions that we've been thinking at ASTREAS has been, what do you do with the meat after it's been grown and cultured in space? Is it okay to eat it right there, or does it need to be handled, prepared, packaged, stored, and so on? So in this presentation, we're going to present to you some of our high-level thinking and brainstorming ideas, and mostly questions that have yet to be answered that we at ASTREAS are thinking about. And all of these are going to play important roles in guiding and helping to develop technical design constraints for the next generation of space stations and spacecraft, especially where astronauts are going to be living off-world, far from Earth, for long durations of time. Now, when it comes to space food systems, there are some elements that are important to consider. This is a list that was assembled by some researchers in the Food Research Lab at the Johnson Space Center. And some of the categories that they have are safety, nutrition, usability, resource minimization, reliability, variety, palatability, and stability of the foods. Of all of these parameters, NASA in particular, and this particular group places a very, very strong emphasis on safety as the number one top priority for a space food system. And coming as a close second is the question of stability. This is the question that seems to be one of the top priorities for developing the next generation of space food systems, for example, for the Artemis mission or a Mars mission, which is how do you keep foods stable for long shelf lives? We're talking 5, 7 years, even longer. This is a big, big area of research that really hasn't been solved yet. All of the other areas are also important, but if the stability question cannot be answered, then it really jeopardizes the future of deep space, long duration space food systems and the associated missions. So for a lot of these parameters that are listed here, I won't talk too much about them, but there are some that are very interesting. So when it comes to safety, what do we think about safety? We're thinking about the biological safety. We don't want the astronauts to get sick from eating the foods. This could come from either the foods themselves going bad, or we don't want the food to be interacting with chemicals that could maybe poison the astronauts or cause some other toxicity. So for example, all the surfaces that the food comes in contact with, we have to make sure that those surfaces are compatible with the foods and won't cause any harmful reactions. Physical safety has to do with things like sharp corners, temperatures, making sure that the astronaut doesn't have a situation where they could easily be exposed to extremely hot water touching their skin, or a hot surface of a heating device and they accidentally touch it and cause them to burn. So that would be the safety element. For the nutritional side, this is also a very, very interesting question, which is, how does the body metabolize, absorb nutrients? How stable are the nutrients? What are the adequate amount of nutrients that astronauts need in order to be performing healthy and effectively in space. Usability has to do with like human factors, user interfaces, how easy is it to use a machine? How easy is it to get your food? And from the time you're hungry to the time you're eating, minimizing that time. And all of these other elements that are listed here, I think are fairly self-explanatory. But these ones that I focused on, stability, safety, nutrition, usability, these are some of the elements that sometimes might be put at a really, really high priority and other times at a very low priority. So for example, usability, we know it's important, but in light of some of these other parameters that are listed here, usability often might get pushed down the importance list and not really dealt with until they're forced to deal with it. So that provides a little bit of context of what we have found in our discussions with NASA and reading the literature. And so that has helped us to hone in as a company on which of these very broad topics is there room for innovation that we as a startup can help address, while NASA and some of the other research institutes are focused on some of the other problems that need to be solved. So some examples of challenges when it comes to thinking about space food systems has to do with resources. You don't have an infinite amount of space, mass, or power that you can use for your equipment, and so you're going to be constrained by these parameters. So on the left, there's an image here of the Melissa project at ESA, and essentially what Melissa is, it's a as close as possible closed loop life support system. So a system that provides oxygen, water, and nutrition, for example, to the astronaut. And it's able to recycle, for example, the urine, the waste, the carbon dioxide that's breathed out, and then cycle it back. And to make that system as close as possible. It's not quite there yet, but you can sort of see the size of the system. We're talking about large warehouse size equipment. And one of the challenges is how do you compact the system to then fit into a more confined region, such as this is the ESA module on the International Space Station that's currently in orbit around the Earth. And so one of the challenges is miniaturizing and making things as small, as compact, as light, and as power efficient as possible. Now, another element of space food systems is how the food is actually prepared. So currently, NASA's Johnson Space Center will either prepare meals and they'll prepare the meals and do all the work that needs to be done to get that food to space, or they may have subcontractors or even purchase from commercial entities foods that are fairly ready already to be flown to space and just have to have minor tweaks done to them in order for the foods to go up. So this is an example of some of the kitchen facilities at the Johnson Space Center where they'll prepare some of the foods. And it looks like the food preparation, you're pretty much using equipment that you would find in an industrial kitchen, like at a restaurant, for example, to prepare your meals. And so one of the questions that comes to mind is, what would this look like if it's the astronaut who has to prepare their meal while in orbit? So they've grown their carrots, their lettuce, their vegetables, and they want to prepare a meal. How should the galley look like in order for them to be able to do that? Accounting for space, volume, power, and again, the reduced gravity environment, it might be very close to free fall. It might be Martian or lunar. And so how does that impact this procedure of cooking? One of the other things that we learned when talking to astronauts and food scientists, and this is all in the context of the NASA human spaceflight program, is that the astronauts do get a choice in testing out foods from different food items on the space food menu. and they get to rank and select the foods that they would like to have on their mission. And their input is taken into account in addition to the medical requirements from, for example, flight surgeons and the aeromedical doctors. And so a tailored meal plan can be produced for each of the astronauts that flies to the International Space Station. And they'll probably spend a day or two ranking the foods, tasting the different foods, maybe even suggesting some tweaks that they would like, so that when they're in space, they'll have meals that they would like or that they hopefully will enjoy when they're up there. And once all the foods are made and prepared, the foods have to be treated and packaged for spaceflight. And so that might be done by subcontractors or at a NASA facility. So the treatment to the food could be dehydrating the food, thermostabilizing the food, irradiating the food to help kill bacteria, and then vacuum sealing it to pull out as much of the air as possible to make things as compact as possible, reduce the volume. Dehydration has to do with reducing the mass of the food, but also increasing the shelf life, because less water likely would mean less microbial activity, for example. And so the food is packaged, it's packed into either the spacecraft or the resupply capsule, and then launched to the astronauts. And so that's a really great thing about being in orbit around the Earth, is that you can get resupplied during your mission. Now, when it comes to the food handling and the preparation, what we're trying to do is keep the safety as a priority. And so what that means is, we want to minimize conditions where bacteria can grow or mold can grow and cause food spoilage. And so the image on the left is showing an E. coli bacteria, and this can lead to food poisoning if it grows on food that isn't properly treated before spaceflight. Now, the food that the astronauts get, it's packaged, and on the NASA side of things, the packaging is mostly plastic. So it might be polymers, or it might be metallic films, or multi-laminate layers of these materials. But you get a sense here of there is a variety of foods, and they are packaged. Some of the packages are opaque; you can't really see what's inside. Other packages, you can see the food. And I'll leave it to you to decide whether or not this looks appetizing. Maybe if you're really hungry, it won't matter. You'll eat it. But maybe the color or the texture might turn you off. You don't know. And so one of the questions that we're thinking of at ASTREAS is, what could food packaging look like in a reimagined way for a deep space food mission? And what would that allow in terms of the food texture, in terms of the food color, and so on. And I wanted to show these two photos here. The one on the left is Valentina, who was the first female to fly to space. And she's eating or sucking food from like a toothpaste tube, essentially. And so that was what space food looked like almost 50, 60 years ago. And on the right, I believe this is for the Mercury missions. It's showing what the food looked like even back then. And so what I want to emphasize is, over the past maybe 50 years, space food really hasn't changed all that much. If you look at currently what's done on ISS versus what was done almost 50 years ago. And so the question is, why isn't there really a big change, at least in the way food is looking in this qualitative way? And what opportunities exist for us to innovate a new space food system, especially one for deep space and long duration mission? This is what the galley looks like on the space shuttle. And there was enough room to maybe have 2 or 3 astronauts help prepare the foods all at once. or one astronaut would be allocated the task to help prepare the foods for the crew members. But I wanted to show, like, this is what a space galley looks like, at least in the space shuttle. And on the space station, this is really the main tool that's used for preparing food. It's a rehydration station, and you can control the amount of water that you're going to inject and the temperature. You've got hot water and warm water. Those are your two options. And that's going to be your interaction with the food prep. And so you inject water into the pouch, it fills up, you pull it out and you squish it around to help mix the water. And then you cut open either the top or the sides, you peel back the pouch and you scoop up your meal and eat it. And it doesn't matter if it's spinach or shrimp or beef. That's the texture that you'll be getting. It's that wet texture from the rehydration and squishing around of the food. This is what the table can look like when it's set. I believe this is, yes, on the International Space Station. And you can get a sense of, for one meal, the space that's needed to be laid out to prepare the meal. And how things have to be strapped down or Velcroed down. Sometimes they'll use magnetic strips to help hold utensils down. And so it's a lot of work, a lot of effort. And you've got a lot of different packages, cans, plastics, cardboard boxes, and thinking about the flow of how that food is being interacted with, from getting it out of storage, bringing it to the table, and then opening the cans, managing all of these different things in a near free fall environment. And yeah, it can maybe get a little bit hectic. But right now the layout looks pretty neat. Here are some more examples of foods on the International Space Station, I believe. And here the emphasis is on the cans. And so half the food currently on station is provided by the Russians, by the Russian Space Agency, and the other half are provided by the other partners, NASA, JAXA, ESA, and so on. And so there's pros and cons of using cans versus plastic pouches. You know, cans are heavier, the waste is bulky, but when you open the can, the food doesn't necessarily need to be rehydrated, and sometimes the food looks nice. Like, you can see the food, you can see the texture. Whereas in the pouches, yeah, it's easy to compact and store, and when you're done with it, to compact the waste. But the trade-off there is you don't quite have the original texture. At least you're losing some of that texture of the meal, and it has to be rehydrated sometimes, and so on. So some of the questions are, what should the future of food packaging look like? Should it be cans or plastic pouches or something else? And then this is an example of what a meal can look like for the crew. I believe mealtime is probably one of the few times where the full crew can have a moment to get together and to let their hair down in the expression, to just, you know, be relaxed with your colleagues and not so much minded on the mission and on data collection or doing an experiment, but just relax and have time to enjoy the meals. And so camaraderie is built over the meals. And sometimes there might be a language barrier or cultural differences. And at the meal table, those differences tend to disappear. And so the table that's shown here, you'll notice there's not a lot of room on the table. There's probably room for 2 people to really sit comfortably and interact with the food. But there are 1, 2, 3, 4 other astronauts not at the table that also have to enjoy their meal. And so this comes to the question of, you know, thinking about the space galley, what should it look like for a long duration space mission? Should emphasis be placed on having even a table that's large enough so that the full crew can sit together and enjoy meals together? So these are some of the big open questions that we're thinking about at ASTREAS, and thinking about designing what a galley should look like on a spacecraft. I have this photo here to show pizza night on station. I don't know if it comes across on the video, but does that look like, appetizing pizza? Looks can be deceiving. We've spoken to some of the astronauts and they said it wasn't the best pizza they've had. And so, just thinking again about the crew interaction with food and how the galley really plays a role in how the crew interacts with the food and the types of foods that they can enjoy. Pizza is great because it allows them to have something different than canned food, than the rehydrated foods. But even pizza still doesn't have the textural contrast. It's still soft foods. And so one of the things we're thinking of ASTREAS is how can we design meals that aren't just soft, but would provide the astronauts with very satisfying crunch experiences without producing crumbs in space. I have another photo here of a meal. This would be, I think it's a Japanese meal that they're enjoying. If you can't tell, it looks like it's vegetables with meat on a bed of rice. And I thought the bed of rice is amazing because if you think about rice and in a microgravity environment, those rice grains can float around and really cause havoc. But not necessarily. Here's an example where rice can be enjoyed in space with chopsticks. And so this really changes or opens up thinking of what future space food systems could have. Rice cooker in space, I don't know, but these are some of the opportunities that may exist. And then here I have a collection of some foods from Japan, or the JAXA on the top left, from Korea on the right, and at the bottom left are some of the Russian foods. And so you can see that there's a tremendous variety of foods on station, but the common theme here is most of them are soft, and most of them are in this packaged state that might impact your perception of how well it's going to taste and your enjoyment of the food. And so the opportunities, again, exist of what types of foods, how should they be packaged, what are the trade-offs, and how does that impact the galley design? I have this photo here to highlight one of the few items that provides a satisfying crunch to the astronauts, which is a fresh apple. But these are not sustainable for a long duration space mission. Like, apples and fruits can go bad and spoil unless there's a way to help preserve it, maybe refrigeration or something along those lines. Right now, the fruits are supplied fresh in the case that's seen here, and it's not every day that you get a fresh fruit. You've got to wait maybe for every resupply or every other resupply. And I have this photo here of some astronauts. Greg Shirmatov is in the center. He's one of our very brilliant advisors, but he brought bagels up in space as part of his personal package. And normally bagels would not be part of the space food menu. But astronauts have the ability to say, I really want something in my personal food stash, and NASA will work to make it happen. In this case, they flew up a fair amount of bagels from Montreal, which was great. And so the packaging here is just off the shelf. It's just a bag of bagels, probably freshly made. And again, it opens up the question of bread makers in space and how do you deal with the crumbs? Is it that much of an issue? Maybe it is, maybe it isn't. And so these are some of the big questions that will impact potential future designs for space food systems. Now, you probably notice there's a lot of packaging, plastic packaging, metal cans, and so on. All of these packaging, after you eat a meal, You think 6 crew members, each one maybe opening up 3 to 4 different food packages, having the meal, and now all of that plastic and metal has to be disposed of somehow, and it ends up in the trash. And so Don Pettit is here taking out the trash, and so the trash has to be, compacted as much as possible, perhaps maybe cleaned a little bit because you don't want it to smell while you're waiting to get rid of the garbage. But it takes up space. It's a sustainability problem. And these are big questions that have to be talked about for on the moon. You don't want to generate trash and litter the moon, for example. On Earth right now, on station, it burns up in the Earth's atmosphere. So the trash accumulates on station, and then you put it in basically a garbage disposal capsule, and you have it burn up on re-entry in the Earth's atmosphere, and the trash is dealt with. Don't really have that as an option if you're on a deep space mission to the moon, Artemis, or to Mars. And so how do we deal with trash? It's another question that has to be thought about on a space food system. Here, this is just showing the resupply. So astronauts have this ability to get food supplied from Earth to station. And like we saw, it could be fresh foods, fresh fruits. Sometimes it might be like a frozen treat, like a popsicle that might come up. But on a deep space mission, the resupplies are going to be less frequent to Mars or the moon. And so either you send the food ahead of time and have it ready for the astronauts, and the food should be enough to last them for years at a time, which comes back to the shelf life question. Or the astronauts can grow their food on their way to Mars or to the moon or on the habitat. And so this comes into the food production and thinking about food production, getting and harvesting the food, whether it be plant or meat or insects or mushrooms or aquaponics, hydroponics, aeroponics, whatever it is, you're producing that food. What do you do with it? You can't eat it all at once. Maybe you can, but you grow it, potentially you got to harvest it, you got to clean it, you got to store it, and maybe you got to cook it. And so these are some big research questions that remain to be answered. Here it's a photo on the Russian side of the International Space Station, where the cosmonauts are working on a payload by Aleph Farms. And Aleph is one of the groups that's leading cultured meat production in space, 3D printing meats essentially in space. And so here they're testing out growing the cells and potentially growing the meat. And what they're hoping to produce is something that looks like this. So this is 3D printed meat that was biocultured by Aleph Farms. This was done on Earth. And you can see that the meat has muscle, it's got fat, maybe cartilage. And so the ability to tune what that meat looks like is very important and can be tuned to the astronauts' specifications and liking. The size of the meat, the thickness, essentially the cut of the meat can also be controlled. But the meat is grown. I don't think the astronaut's going to eat this raw. The meat has to be cooked. And so the goal would be to take that meat that's cultured in space, and then what? Well, we got to cook it. And so thinking about what that should look like. So this is an example of that 3D printed meat being cooked. And this is on Earth, of course, but looking at the presentation, there are sauces, seasoning, greens, and potatoes. And so on a space mission, all of this stuff can be cultivated and grown. But the question you'll notice is, how should the foods be prepared and handled and dealt with? What if there's a lot of meat that was grown? You don't want to throw it out. That was a good resource. Where do you store it? How do you store it? How do you make sure it's safe and so on? And then just from growing beef, there are so many meals, so many variety of meals that can be produced. And probably I don't need to emphasize how great it is to have variety on the menu, different styles of foods and so on, different tastes and textures. All of these are starting with beef. But again, the question is, how do you cook these meals? How do you prepare them? And this leads into the importance of having a galley, because from that one ability to produce cultivated meat, you combine that with a well-designed galley, and now you can produce a huge variety of foods that the astronauts can enjoy on their long missions away from Earth. So what should a galley on a spacecraft, space station, or space habitat look like? Well, this is one of the big questions that we at ASTREAS are thinking about, and we welcome anyone who has an interest in helping to address and solve and design a space galley to reach out and contact us. I'll share a slide later about contact information. So for inspiration, or maybe just for context, this is the kitchen in a food truck. And so you'll see that in a food truck, there's a lot of hardware, even in a truck, in a food truck. And depending on what types of foods are being produced and made, there might be variations in what this looks like. But the layout here is linear. It's the flow of the chef, if you will, in the kitchen is going to be from one end of the truck to the other end, sort of that linear fashion back and forth. That's the flow of the interaction of the chef with the kitchen. This is another galley. This is in a jumbo jet. I think it's in the first class kitchen where the flight attendants prepare the meals. And you can see that the layout and the flow is different. Here, there are 3 walls that have cupboards and storage at the top, at the bottom, and in the middle region, there is counter space all around, so that the flight attendants can put trays down and get things on the table and prepared and organized. And in the larger cabinets, sort of at the chest height, those are some of the equipment related to cooking. So heaters and coffee makers and so on. So this is another example of how the types of food is going to sort of impact the galley, and how the flow of people in that galley is going to work. Space is tight, but it's functional, and you can see here 3-4 people can fit and work easily around each other. I say easily, relative term. And this is the kitchen in a polar research vessel. This would be a boat that might be 3-4 months at sea, and this is the kitchen that's in the boat here. And so you can see the flow here is very different. Now all 4 corners of the wall are being used, very circular motion of the crew members or the chef and the kitchen crew as they interact. And you'll notice that some of the heavy cooking is at the center. So there's sort of meal prep on the outside with sinks and so on, refrigeration on the outside, but then the food handling and the food prep, cooking and prep and so on seems to be on the center here. And that's different than what we saw in the food truck setup and in the jumbo jet setup. And so all of this is thinking about, well, if we're in a spacecraft, what should the galley look like? If we're in a space station, what should the galley look like? If we're in a habitat on the moon or on Mars, what should the galley look like? And they may be very different depending on the size of the crew. All of these examples I've shown here, they're feeding about 100 people a day. But on station, on a deep space mission, it might be just a handful of people a day. And so, thinking about what the layout and the interaction, the flow of people with that galley is going to be like. And then the final photo I have is of a submarine. And I feel, personally, like a submarine is probably the closest we can get to an analog on Earth of what it might be like being in space, because this is truly a closed loop system for months at a time. You're in an environment where you're not necessarily stable things can rock back and forth. And so the galley here, it's very interesting to see how a galley in a submarine makes use of every nook and cranny in a very strangely shaped bulkhead to make a functional kitchen. And again, they're feeding about 100 people a day in here. I have here some photos of what galleys look like on space stations. So this is Skylab, and this is actually on Earth. This is just a training model. But you can see here that there is a heavy emphasis placed on the ability of having the crew to be together and eat together. And so there's room here for everyone to fully lay out their meals, interact. There's elbow space to use utensils and get down close to your food if you need to. And so, yeah, it's a fantastic contrast to what we see currently on the International Space Station. Now, we talked about the galley, the layout, the flow, but we also have to think about the utensils, like what goes into the galley, like what appliances, cutlery, pots and pans, trays, all of these things have to be thought about. And so you might think about your typical kitchen. You might have every single one of these items that are shown on this left graph, image. But I can guarantee you that on the space station, they probably don't have more than 5% of what's shown here, if that at all. And you probably have a lot of these pots and pans and trays in your kitchen, but you won't find them at all on the space station. What you will find on the space station is sort of what's shown here. This is a food tray, and this is Vicky Cloris, who was the manager of the Space Food Systems Lab at NASA, and she's actually still there. She's holding a tray and an example of the layout of food, and this would be one meal. So this is the meal for one astronaut, all the different things that have to be brought out, gotten out of storage, laid out, and then eventually rehydrated, heated, cut open, eaten, and disposed of. So it's really thinking about what opportunities exist for us to rethink what this could look like. Now, when thinking about the galley, safety, again, is very important. We talked about microbes, but sharp objects can lead to cuts. So if you're cooking a steak and you need to cut it, how do you do that safely in space? This is an important question. If you need to chop up vegetables, how do you do that safely in space, if at all? Burns, if we're talking about grilling meat or baking potatoes, how do you design your appliances to minimize burns, actually to just eliminate the chance of there even being a burn at all? How do you have cool surfaces on the outside, for example? And then the photo on the right is really highlighting how different things behave in the microgravity environment, especially. So this is a water drop. If you spilled water, in your kitchen, it'll hit the counter or hit the floor, spill, and you wipe it up. But if you spill water in space, it sort of floats around, and it may find itself to electronics that might be above you, below you, to the side of you. And so there's another safety element there of how do you deal with splashes. It might be splashes from water, it might be from other sauces, and not just water, but you may have seasonings, grains, salt. You might put the salt in water and then put that water on your food, but nonetheless, how do you deal with these particulates or liquids that might float? And these are just some examples of the questions that have to be answered when thinking about designing a galley for a space-like environment. So now I'm going to dive down into some of the appliances, and this is coming now into the home stretch of the presentation. So one appliance that you might find at home is a water heater, right? You might need to have really hot water for your tea, or maybe you're making instant noodles at home, and so you'll use your water heater, quickly heat up the water and use it. So there is something equivalent on the International Space Station, and it's this potable water device. And it looks complicated, but really you're just controlling how much water to put in, and you have choices of two temperatures, either like hot, but it's not really so hot to scald your skin, and warm. And this is the water you'll use to rehydrate your foods or for drinking water. And so if you don't want to drink hot water, well, you're going to inject the warm water. And if you don't want to drink warm water, you got to wait for your water to cool down at least to room temperature inside the station, and then you can drink it. So now we talked about hot water, but what if you want to drink cold water? Or if you want like an iced tea drink or something? Well, that currently isn't available on station. And so what's the importance of having hot and cold water in your kitchen when you cook? And think about that for now you're on Mars. For sure, you're probably going to want to be able to have both hot and cold water if you're on a 3-year mission on the way there, and also potentially on the way, hopefully on the way back as well. This is another appliance that you may have in your kitchen. It's like a grill press. It can be used to make sandwiches, or maybe even to cook like chicken breasts or steaks. And there is something somewhat similar on station, though nowhere near the temperature that you would have in your kitchen. What's on station is like a briefcase style heater. It's a reheater essentially. So some items on the space food menu don't necessarily need to be rehydrated, but they may need to be heated. And so you can use this this heater briefcase. You put your food packets in there. You can maybe put 4 to 6 packs in there. You close the briefcase and it heats the food up. Again, it's not so much that it's hot, like piping hot. It's just warm. So you're not having cold food, and you can enjoy the flavor at least that much better when it's warmer. Now, up until just I think last year, there wasn't a fridge on the space station, nor a freezer for food. And you can think about, imagine a kitchen where you don't have a fridge. Wow, I can't imagine that. And so that's the case right now, or was up until just a year ago on the International Space Station. There's no fridge. And so the foods, that's one of the reasons why the foods had to have such a high shelf life. You know, you may need to have a supply of food up there for 6 months, maybe a year, but you have no fridge. And so that's going to limit the types of foods that you can grow and store and keep on the space station. And so this is another important element of a galley. It's like, how do you design a fridge and freezer for a space galley, whether it be in a microgravity environment or on the surface of the moon? And what should it look like? You know, we're used to the size of things on Earth, like a milk carton. We know the size of a milk carton, and fridges will have space for your milk carton. Eggs, we know the size of like a dozen of eggs, and so your fridge sometimes will have a dedicated place for your eggs or your butter. There are these sizes that we're used to, standard sizes, so to speak. And so if you're designing a fridge for space, what would be the standard size? Like, what would be the items that go in there? And how big should you make your fridge? What dimensions? And that's going to tie to the packaging that you're using, and that's going to tie to what foods you're packaging. And so everything is tied together. And it's a little bit foolish to think about designing the space hardware without thinking about these questions ahead of time. And so this is where we're at ASTREAS. And again, we welcome everyone who has an interest in helping to think about these questions and to brainstorm ideas and designs to reach out to us. This was really fun. I actually saw the coffee maker in person when it was demoed at a conference. So there is a coffee maker. I think for most American homes, it's very important to have a coffee maker in the kitchen. And I believe the space agencies felt it was equally important to have coffee maker for the astronauts. And so the Italian Space Agency built and flew up a coffee maker that is installed on the International Space Station. And last I heard, they had a little bit of problems with things not working well. but nonetheless, there's a coffee maker up on station. Some other questions would be like, what do you do when it comes time to like clean dishes? If there are even dishes, what do you do with the waste? So at home, we use plates and cups and spoons, and if they're non-disposable, we can wash them either in the sink or put them in the dishwasher. And the advantage of washing is we can reuse those items again and again and again. And the washing also, disinfects it, so it makes it clean. One of the challenges in space is, how do you do this? What does it look like to have reusable utensils and plates and pots and pans, perhaps? And how do you clean them? How do you wash them? How do you disinfect them? And tied to that is, what do you do with the waste, right? So if you have like a lot of leftover, let's say on your plate, and you want to reuse the plate, well, where do you dump the leftover food that you no longer want? Where does that waste go? So how do you compact it? So here I have on the right an image of some research being done into how to compact waste as much as possible into really flat tiles that can then be stored and eventually disposed of somehow. But another question with a space galley, with all this equipment, is how do you maintain it? If something breaks down, for example, the coffee maker on the International Space Station, how do you repair it? And so along with all the design considerations of mass volume power and the reduced gravity environment, you also have to think about the ease of repair, the ease of cleaning, the ease of taking things apart and putting them back together again. And you may also need to think about spare parts. It would be a shame if you flew, your fridge from Earth to Mars. You get to Mars and 2 days later, the fridge stops working and you can't fix it because you don't have the parts. And so if you can design appliances that use very much the same parts, that's great, because then you can have a few spare parts and the ability to, with those few spare parts, repair a lot of appliances if needed. Another option would be to 3D print parts, either out of plastic or metal or some other material. And if we're 3D printing parts, why not 3D print some of the utensils we use, such as plates and bowls? So here's an example of a ceramic printer on the left, and on the right would be sort of like a stylized bowl that was made. And you can imagine 3D printing a plate, and that plate being used, washed, clean. But if it gets damaged, it could be crushed and reused as material to be recycled in the 3D printer. And so looking at sustainability essentially is another important question. Now, we talked about appliances. Another element that's going to be really important for a space galley are the smells and the aromas. And talking to astronauts, what we found is that the smell of fish, I believe from the omega-3 fatty acid, sometimes can irritate some astronauts. And what I mean by irritate is some astronauts just don't like it at all, the smell. They don't find it pleasant. They don't want to be around it, but the smell will travel. And so if you consider that 50% of the food might be coming from the Russian Space Agency, and a large portion of that might be canned fish, there's a lot of times where you might be exposed to these unpleasant smells. And so another point of research that we're focusing on at ASTREAS is looking at how to potentially design foods and packaging, even if the packaging is open, so that smells are contained within the food and don't travel. And so there's a technology that we're pursuing and exploring to see how feasible that could be. And we're talking about food and eating, drinks. We mentioned coffee, but if you look at how drinks are consumed on the International Space Station, it's typically in these pouches. So you may have like a powder and you add your water, you mix it up and you drink it, and you'll probably drink it from a straw. And some of the astronauts miss the experience of drinking like you would from a cup. And so Don Pettit, for example, was experimenting with the ability to design maybe a cup for use, especially in a microgravity environment where you can rely on surface tension and capillary forces to almost give a sensation like you're drinking from a cup, like you would normally do on Earth. You know, with it open, you can engage now your sense of smell in enjoying that drink, versus if you're drinking from a straw, your nose is not really involved in that experience. And so there's motivation here to think about what some of these utensils can look like, especially cups. And speaking of drinks, thinking about pop, carbonated water, and even beverages like beer and champagne, how can those be designed, and how can they be integrated into a space food system, into a space galley? What considerations have to be thought about so that astronauts can enjoy these, especially on very important occasions? You can think about like a New Year on the moon. Maybe you want to pop some champagne. Well, it would be fantastic if your space galley had the ability to provide that to you. And so again, some really interesting research questions here. And this is coming to my near the last slides. Related back to the question of sustainability, thinking very carefully about the materials that we use in our galley, for the trays, for the utensils, for the pots and pans, for storage, what materials would make sense in terms of reusability and sustainability. So on Earth, there's a push now for biodegradable, recycled items to be used, whether they be plant-based or like biodegradable plastics, compostable materials. And this leads to the question of waste management in the space galley. You may have to separate your compost or your recyclables from your trash. And we need to think about these questions ahead of time, because we do not want to have the moon become our trash can, our next landfill. And already, I think there's something close to 400,000 pounds of trash on the moon. I don't quote me on that, but there's a large amount of trash already on the moon. Here's an image on the right of some trash that's just lying on the surface of the moon for the past 50 years, just from a few short missions. We need to think very carefully about how to preserve the pristine environment of the moon once humans establish a permanent presence there. And the final point is all these questions that we're thinking about at ASTREAS for space galley and space food systems all come back to Earth. Because if we can solve these problems for space, we can directly bring them back to Earth and help meet sustainability goals that the UN has put forth. If we can find ways to minimize the use of power, space, mass, volume in putting together this galley, if we can find ways to reuse and very efficiently wash and clean and disinfect our galley and deal with waste and so on, all of these are trickle-down technologies that will benefit all of mankind as well. And so with that thought, I'm going to bring you to the last slide. Thank you very much for giving me your attention for all this time. Again, we are ASTREAS. We are developing space nutritional countermeasures. But as you can see, we're also thinking about the larger full space food system, especially when it comes to the space galley and what that could look like and the flows and so on. Our website is astreas.co. Feel free to check us out. And my contact information is at the bottom. It's Persad at astreas.space. But you can also reach our CEO, Shireen Riza, and her email address is there as well. Thank you so much, and please enjoy the CMS 2022.